Is AI as intelligent as humans, or less intelligent, or more intelligent, and could
Once
it
again,
become more intelligent?
once again, when we ask these questions, we don't really know what we are talking about ourselves because we don't know what intelligence itself is. Is there a tractable
Let's go to the IQ aspect of intelligence.
to the IQ aspect? Now, yeah, this is where things get a bit complicated. Like when you talk about specifically the IQ aspect, because most of the standardized tests for measuring IQ have effectively relied largely on like very particular kinds of pattern recognition or very particular kinds of like spatial recognition. In a lot of
Yeah.
cases, you have machines that outperform humans, at least at least when you look at like the sort of the normal baseline of humans, a lot of algorithms today can outperform humans on those kind of tests. Now, obviously, that argument remains that to what extent IQ tests themselves are a good marker of intelligence, or
Yeah. Okay. Of course.
so that's where a lot of these questions come. Like we talk a lot about this human versus machine. We talk about Terminator scenarios. We talk about science fiction, but the fundamental idea is this: we do not really appreciate the full diversity of the human race or the human mind itself. How are you going to talk about any comparisons to mechanistic entities that we design? So at the end of the day, I think there is a bit of a more of a room to understand what natural intelligence is before you start getting all uppity about artificial intelligence.
Okay. Okay. Yeah. That's a very fair point. That's a very fair point. So, do you think that in the programming aspect of AI, are we chasing after it to catch up with understanding what it is, or are we actually leading it forward?
So as far as most of the programming aspects go, so far the most dominant paradigms, I mean, you were talking about like stuff like deep learning or neural networks earlier, it has largely been driven by a paradigm known as connectionism. So connectionism is this idea that you can have essentially nodes connected with edges, essentially like directed graphs, but not quite when you look at the mathematical sense, where every node can represent a set of parameterized operations that perform a mathematical operation known as composition. And learning those parameters essentially allows you to learn the patterns that can emerge. Either that, or in a generative sense, to actually learn from a open distribution, to actually create some of those samples that it has learned from by these learned parameters. So effectively, what we are really looking at is programming these kind of like modules where these mathematical parameters can optimally be learned, either based on objective or based on some amount of like probability divergence with the open distribution, the latter case being generative. So in all of these cases, until recently, we did not really see emergent behavior, or as we would call, you know, properties that would not be ab initio explained by by the intent of the, let's say, the original developer. What we do see now is like, with a lot of particularly large language models
Could you say this is like ChatGPT and Claude and all this stuff?
or O1s and all of that, like Mistrals, all of that. In some of this, we do see things like, the emergence of some amount of causal reasoning, and it's not very clear where it's coming from, if it is a result of the data that it was trained on, or if it is something else that we are seeing. So for me, for the question that you asked, 95% of my answer would be that we are still in the realm of where we are programming and we are still relying on essentially statistical learning over reams of data. But there is a 5% uncertainty that I have in my mind that there might be some amount of emerging behavior that we see that we can't really explain straight up by hard coding some of the stuff that we write.
Okay, that's very interesting to see that emerging. But could you say the biggest turning point for AI was the way it initiated from psychology in the 1940s?
So yeah, there is a bit of a
Yeah.
background to that. Like you asked about neural networks earlier. So once again, the first neural networks are not constructed by computer scientists. They're constructed by cognitive psychologists. The first one was in 1954 by I believe it was Robin McCollum, if I'm not wrong. And it was essentially designed neural networks as being like some level of a proxy for neuronal pathways in the human brain. Now we know with absolute certainty that neural networks are by far not an appropriate representation of the human brain. At best, it might be like a cartoon representation of how neurons actually work, but purely in terms of information abstraction, neural networks served as a tool of like conceptual understanding of how information processing might work in the realm of like
Yes, it's a model. It's a model, like all other models in science. Yeah, it's still a model.
this was picked up in the 1964 Dartmouth Conference on AI, which was one of those first conferences where this tantalizing question of can machines learn was substantially addressed. This was proposed as one of those potential ways of like, imparting the concept of learning and intelligence in non-human systems. And at the time, this approach, like neural networks and other connectionist approaches, were competing with a class of approaches known as symbolism. So, like a lot of the approaches of like learning symbolic logic or learning logical workflows through symbolic manifestations thereof. And
But is it that the AI understands actually what the symbols mean or knows how to describe?
it was somewhere in between actually at the time. Like you had essentially a lot of the symbolism used to identify or hardcode essentially elements of logic into mechanistic systems. That was what symbolism at the time was really about. But what happened was that at the time, you did not really get a lot of currency for neural networks for the next 20 years, 30 years thereafter, because it was not clear how you could actually find enough data to train them on or find enough compute to train them on. A lot of it changed in 1986 when you got the first ever backpropagation algorithm. It was out of a master's thesis actually by David Rumelhart, which actually described how you could use gradient flows and gradient descent as an optimization algorithm that could train such connections of neurons. So connectionism actually picked up once again following this discovery. And eventually, in the 90s and the early 2000s, once again, there was not enough data, but all of it changed in 2012 when essentially the world discovered GPUs and the fact that GPUs could be used for parallel computing to actually train some of these large amounts of neuronal circuitries using sort of large scale amounts of data. So the credit of this goes to someone known as Alex Krzyzewski. So Alex Krzyzewski was a PhD student at University of Toronto. He spent close to 1.5 years in his basement trying to get uh, parallelization using GPUs to work. And the world owes a lot to him because that is what heralded the present revolution of connectionism, which is where deep learning was born. Fundamentally, deep learning is nothing but learning using multiple layers of connectionist assemblies like neural networks. So a deep neural network is fundamentally neural networks that have more than one layer essentially.
Okay, okay. And is that the same in simple models? And like we saw recently, I think the first quantum computers being made from NVIDIA, from Microsoft, being able to harness like superpower within just a couple centimeters, uh, yeah, space. Is it the same technology, only more advanced, or is it completely different from simpler AI models?
We are talking about slightly different topics here. Like when you talk about most of quantum computing circuitries, you are really talking about essentially, being able to go beyond what are known as hybrid classical quantum systems to actually pure quantum states. But that that line of discussion is slightly tangential to deep learning or artificial intelligence because you do see very strong intersections today. Like quantum machine learning is a thing, quantum deep learning is a thing. Doesn't work very well in a lot of cases, but in some cases, like in pharmaceutical drug discovery, specifically in modeling, for example, like chemical reaction uncertainties, quantum machine learning has shown quite a lot of promise. So slightly different topics, but there is a strong intersection to that is increasingly being discovered.
Okay, okay. So, is there potential? Do we know anything about what potential could exist in AI? What is the ceiling that we could reach or no?
Well, I mean, one of the ceilings that is often quoted is this idea of a singularity. Like, when artificial general intelligence becomes intelligent enough that it is indistinguishable from, let's say, the larger human society. But if you ask me, I don't think like there is a possible like understanding of what singularity might look like. So if you ask me, the ceiling would essentially be the emergence of like causal reasoning and independent behavior essentially. So for example, you look at babies. Like when babies are born, they are born essentially with limited knowledge, at least something, they're not really taught a lot of things, but they do learn to figure out through exploration and exploitation how to navigate their way in the world, even without explicitly being taught to do a lot of these things. So the moment you have algorithms or say any of these foundation models or language models or multimodal models, whatever, the moment they're able to demonstrate this kind of behavior, where they're able to interact with like so what are known as world models or open world data and come up with essentially independent judgment and independent reasoning, that would be the holy grail moment for me.
So, is that a conversation of consciousness as well?
Once again, we don't know what consciousness is. We don't know how to define consciousness. Like the philosophical definitions of consciousness, all of them end up in a recursive loop across cultures, across philosophies. And when you talk about this idea of consciousness as being able to take in and impact your surroundings and feel one with it, maybe if an algorithm is able to kind of take independent action based on its interactions with open world data without explicitly being trained for it, that may be some form of consciousness that it might demonstrate at that point. Roman,